Hello viewers, welcome back to our YouTube channel. Today we want to proceed with our series of quantitative techniques, and as we had spoke in the previous video, we said we are going to start our chapter 3, and of course our chapter 3 is all about sampling techniques. Chapter 3 is all about sampling techniques. So this is our chapter 3. Chapter 3, that is sampling techniques. Sampling techniques. Sampling techniques. Now, of course, by the end of this chapter, we have some objectives that we intend to achieve, that whoever finishes this chapter of sampling techniques will be able to have achieved, if they are told they have completed. One of the objectives that we intend to achieve at the end of this chapter is to identify the various sampling techniques, and we'll be able to give their advantages and disadvantages. So first of all, we identify the different sampling techniques and then be able to give their advantages and disadvantages. The second objective that we intend to achieve under sampling techniques, we intend to describe the sampling techniques that are commonly used in business and commerce. Of course, we also to know to get to an understanding of how these are divided into what we call the major categories. Of course, as we know them, the random sampling, the coarse sampling, and then the non-random sampling categories. Of course, the third objective is to be able to describe the sampling techniques that are commonly used in business, and as well as being able to classify the sampling techniques in the different categories. So we need to understand that if we talk about maybe probabilistic sampling techniques, if we talk about the non-probabilistic sampling techniques, which are they, and can we define them? Can we know which belongs to which category? And then are we able to understand the differences between those different categories plus their advantages and disadvantages? So that's the overview of this chapter 3 of sampling techniques, about the things that we are going to look at. So without wasting more time, let's try to understand what sampling is all about. Of course, sampling refers, if we talk about sampling is a process, sampling is the process of obtaining information about the entire population. Process of obtaining information about the entire population. Process of obtaining information about the entire population. By examining. Process of obtaining information about the entire population by examining part of the population. By examining part of the population. By examining part of the population. By obtaining part or by examining part of the information. Now, when you look at sampling, just by knowing it is just the process of obtaining information about the entire population by studying part of that population. The main aim of sampling is actually for us to be able to get a sample which will be a representative of the entire population. So we are trying to get the sample that we can use to be able to understand the different characteristics of a sample of a population. The other definition that we can use, if we have not defined the sampling in that perspective, we can say sampling is a process is the process of using a smaller number of items or parts of a larger population parts of a larger population, to make conclusions, about the entire population, Of course, the other key thing that we need to note is the fact that sampling can be with replacement, whereby a member of the population may be chosen more than once. We can have sampling with replacement, whereby we have seen that a given member of the population can be selected more than once. Or we can also have sampling without replacement. Without replacement, where a member of a population may be chosen once. Like when they choose one person, they don't put back that person in the same population. So there could be two scenarios where we are picking a certain member from the population, then we put that member back and is also eligible to be chosen for the second time. Or it could be a situation whereby we just pick the member, we don't replace that member. So as we have seen, or as we saw when we talked about a sample, we said a sample is just a subset of the entire population, or it is just some part of a larger population representing the entire population. Now, one key thing you need to understand is that a sample can be drawn using two methods, or using two ways. There are two ways in which a sample can be drawn. It can be through what you call probabilistic, or what you call the probability sampling, procedures, or what you call the non-probability sampling procedures. So we've seen there are two ways of how we can pick the population, either by using the probabilistic sampling procedures, or using what we call the non-probabilistic sampling procedures. So those are the two ways. In other words, those are the categories. We are going to have a category that is probability or that is basing on the probability, meaning we are basing on chances. Then we also look at another aspect, how we can choose the sample from the population with what we call the non-probability sampling procedures. So what we need to understand before we go into a deeper analysis of what we call the probabilistic and then the non-probabilistic sampling procedures. We need to understand why do we really need what we call samples. As samples, really, why do we use samples rather than using the entire population? Of course, we looked at some of these things, but we want to repeat ourselves so that we can be able to get a deeper analysis of what we are trying to look at. So why do we need samples, or why do we do sampling? Why do we sample our population? Why do we sample our population, or the advantages of using a sample over the entire population? Those are the things that we are going to look at. Why do we sample our population? Or the advantages of using a sample over the entire population of study. Of course, one of them we can use, one of them is that we will have a reduced costs, reduced costs, and enlarged scope. Reduced costs and enlarged scope. Now, I want to understand, of course, sampling involves collection of data on a small number, or basically using a smaller number of units in comparison to the complete enumeration. Of course, when we take up a small portion of the entire population, we are going to be able to study that small population, that small number of units or items that we have selected from the population. We study them as we compare them to the entire population. So that is going to involve into things that will help us to reduce costs, because the moment you are studying a population, you are going to be spending a lot of money. If maybe you are covering people of Uganda and you have to travel all over the country to get information from each one of the people, you find that is going to be very expensive. But if you are just sampling very few people, maybe from different parts of the country, then you can save on costs that you would have spent if you had to interview all the people. So the costs involved when you are interviewing a smaller number or a smaller items as compared to the population, the cost of collection of information is going to be reduced. And of course, in addition, the information can be obtained at a very little cost compared to conducting a separate survey for all the people. For example, if let's say when an interviewer is collecting information on maybe health conditions, and you find that maybe he or she asks some questions on health practices, of course you find that this is going to provide you with additional information on health practices, and the cost will be much less than conducting an entire survey on the health practices. So what we are basically trying to look at here is that the moment you reduce on the number of people you are going to interview, maybe the number of people you are going, the number of items you are going to study, the lesser time you will take, and then the lesser money will be paid. But at the same time, when you talk about the enlarged scope, it means when you keep selecting these samples, you can be able to study a very larger population. Like you can study a lot, because you are going to have more time to interview a small portion of the population. Then you can make a generalization about the characteristics of that population by just basing on the sample that you have collected. So you can get, I can maybe interview the whole of, let's say, East Africa by maybe choosing maybe 100 people from each of the 5 or 4 countries that I have selected. So I can decide to select maybe from each part of the country. I pick one person or 2 or 3. Then I also do the same for the other country, and you'll find that I have interviewed maybe the whole of Kenya, but I've or the whole of East Africa, but I have just picked out samples from each of the countries than it would have costed me if I'm to interview every person within East Africa. So that's the reduction in costs and then the enlarged scope that we are talking about here. The other aspect is that organization of work. Organization of work. Organization of work. Now, when we talk about organization of work, it is very easier for us to manage it is easier for us to manage and organize the collection of data from smaller number of units than collecting information from all the units within a given census or a given population. For example, if let's say if I'm to draw maybe a representative sample from a state, let's say Uganda, it is very easier for me to manage and draw small proportions maybe from each city. I can pick maybe a small group, a small sample from every city, and then I call that maybe that is sample A, sample B, depending on the different cities that are available in that very country. So that would save me time, and even the information I can organize it because I'm going to be interviewing very few people as opposed to interviewing the entire state, meeting each and every person. So because if you meet each and every person within the population, you are going to get to end up with a lot of information, and it will be hard for you to to manage. So the moment that you tell yourself that you are going maybe to organize small groups of people, interview them, they know what you are intending to achieve, of course you'll end up with what we call an accurate information. And of course, when you have an accurate information, it means that you are going to draw accurate conclusions, because you'll find that this data that you have collected from the samples, you have been able to organize it very well so that you can be able to draw an improved inference about such a population of study. The other point that we can talk about is, of course, we have greater accuracy. Greater accuracy. Now, when it comes to accuracy, of course, the person that is involved in the collection of data, these people are going to be trained. They are trained people or trained persons. So if these people are trained, then they can be able to collect data accurately if they have collected a small number of items from the population than studying the entire number of units within a given set of data or a given population. So the information we are going to get a very reliable information, because we know that samples can actually provide sufficient and accurate findings, because we know that these samples are actually a true reflection of the attributes of the population they are trying to study, because these samples are going to be selected from the the population. The other item that we can talk about is urgent information required. Urgent information required. Of course, we know that the data from the sample can be quickly summarized. So once you can summarize the data quickly, it means you are going to give the information depending on the urgency need of it. For example, if let's say I'm forecasting the maybe crop production, you'll find that it will be very quicker, or it will be done quicker on the basis of a sample of a given set of data than collecting all the observations or all the attributes of the population that we are put under study. So the information, we are going to get urgent information because we are studying a slightly smaller population, a smaller sample size. The other one that we can talk about feasibility. Is it feasible? Most of the times it is hard for researchers to actually conduct research on entire population because of the fact that the resource and then budget constraints. Of course, the limited resources in terms of the budget constraints and even the time constraints. So since we are not going to have the resources being available for us to carry out the entire study of the entire population, we will end up doing what we call the sampling of the population. We study a few elements of the entire population, but we also have to make sure that the sample that we have picked is a representative of the entire population, or it has the attributes of the entire population, so that we can be able to draw meaningful conclusions. Then maybe lastly, we can talk about what we call the accessibility. Accessibility. Accessibility, of course, we find that not all the population elements are accessible. Of course, there could be existence of things like physical impossibilities to check all the items in the population. So you may find that maybe some areas they are hard to reach areas, some areas maybe because of the terrain, maybe because of the infrastructure, we can't be able to reach some of the people within the population or within the area of study. So these are some of the reasons as to why we study a sample as opposed to looking at the entire population. So now let's look at the two sampling techniques that we had spoke about earlier on. We've said they are probability sampling procedures and then the non-probability sampling procedures. So we want to start by looking at what we call the probability sampling, or the probabilistic. Sometimes they call them probabilistic sampling techniques. Probability sampling. And we've said that sampling techniques, they fall under the category of what we call probability. And most of the times, if they don't use the word probability, they call it random. So let's also put this one, random sampling. They don't call it probability sampling or probabilistic sampling techniques. They call them random sampling techniques. And then we also have the non-probabilistic or non-probability or non-random sampling techniques. Now, the probability sampling techniques, of course, definition-wise, these the probability sampling techniques or the probability sampling. This is the type of sampling. This is the type. This is the type of sampling. Type of sampling where is the type of sampling where each unit where each unit of the population has equal chances has equal chances of being included in the sample. Where each unit has equal chances of being included in the sample. Has equal chances of being included in the sample. So probability sampling is the type of sampling where each unit of the population has equal chances of being included in the sample. So a probability sample refers to a random sample, and a random sample is one in which every member of the population has equal chances of being selected. A random sample is a sample in which every member of the population has the same chances, or it has equal chances of being selected to be part of the population, or to be part of the sample. So the random sampling, or what we call the probability sampling, is the type of sampling where each unit of the population has equal chances of being selected. So in this kind of method, we said if they don't call it random sampling, they call it probability sampling. And in this method, each item of the population under consideration has an equal chance of being selected as part of the sample. In other words, each item or each subject in the population is selected independently. So each item is going to be selected independent of the rest of the other items. Now, of course, we've known that there are only two types or categories of sampling: the random sampling, or what you call the probability sampling, or probabilistic sampling methods or techniques. But within the probabilistic sampling techniques, we have very many types that we are going to look at. But the bottom line of all the sampling techniques that fall under the probability sampling techniques, all of them are going to give each item of the population equal chances of being selected. What is going to be changing for each of these methods is how they select the items from the population. But the bottom line is that each of the members of the population will be given equal chances to be selected. I hope you are getting the whole idea. So let's start off by looking at the categories of all the types. The types of random sampling techniques. Random, or what we call the probability sampling techniques. So the first one that we have under the probability sampling techniques, we have what we call the simple random. Simple random sampling. Of course, the simple random sampling is the technique that is, of course, the technique that is mostly used, and it is the very basic method among the probability sampling techniques. So, simple random sampling is where the is where we use the idea of listing all the sampling frame. So we list all the members of the target population and we give each member an equal chance of being selected to be part of the sample size that we are collecting. So for a simple random sample is a kind of a sample, or is that type of a sample in which every possible sample of the same size has the same chance of being selected. Now, one way to collect a simple random sampling in other words, one of the best ways to collect a simple random sample is to assign each number to each number of the, or each item, or each unit, or each member of the population, and then maybe we assign it a given number, maybe a number 1. Then what we do, we use maybe a random picking of, maybe we can we can maybe write, maybe we can use plain piece of papers. We write there a number, then we fold the papers. Maybe we use a table, we pour all those squeezed papers that we have used where we wrote different numbers. Then we just pick one at a time, and then we pick, then we cross check, we see which number we have included in our sample. So when you are picking these items, each of the members or each of those squeezed papers will have the same chance of being selected. Like for instance, if you look at how they do it when it is maybe football matches, maybe UEFA Champions League quarter final or semi final, they just pour those, they write the teams on the piece of paper, then they pour them in a given bottle, then they shake, they just pick one at a time, and that's how they get to select who is going to play who in that kind of sense. So it is the same idea that we apply here. But remember, we said there is when you pick a sample without replacement, and then there is when you pick a sample with replacement. So if we are to pick an individual using what we call a sample with replacement, it's going to be like an individual who is going to be selected is going to be removed from the population and cannot be chosen again. So when we remove a piece of paper, we don't put it back. What we have put, when we remove, we don't put it back. It means that the number of items within the population keep on reducing whenever we pick an item. But when we are using a sample with the replacement, it means the selected individual will be placed back into the population so that they can also have another equal chance of being selected. So, of course, maybe you can have some examples. Of course, we've said that under this method, we've said that this method uses a sampling frame. We said the sampling frame is just a list of all the items that are going to be part of the population. A sampling frame. This method uses a sampling frame that lists all members of the target population. Giving each member an equal chance of being selected in the sample. Of course, this method is the one that is more applied. And among the areas where we, or some of the examples, or some of the cases where we have seen it being applied, of course, if we look at maybe when UNEB is trying to test the efficiency, if let's say maybe we are trying to look at the UNBS, let's look at the UNBS, Uganda National Bureau of Standards, UNBS, Uganda National Bureau of Standards. If at all the UNBS is trying to test the efficiency of, let's say, some fuel pumps in different fuel stations, they can assume, if maybe they are looking at fuel pumps and they are testing the efficiency, if UNBS is maybe trying to test efficiency of fuel pumps in fuel stations, of course they can say that we are going to take, maybe they can say the sample is going to be maybe 25% of the fuel stations of the fuel stations in one town. So they can take 25% if, let's say, a given town has maybe, let's say, 20 fuel stations, and they take 25%. So you find that they now look at that as their sample in that town. Then they go in another town, they also go in another town, and they test. The other that we can talk about is maybe if maybe you are looking at the auditors. Of course, auditors, they can sample company invoices. They can assume that, they can make an assumption that we are going maybe to take, let's say 10% of the company's invoice, and they try to check the completeness and then compatibility with the total yearly turnover. Of course, they get those invoices, maybe 10% of the company's invoice for a given period of time. They try to test some of them to see whether these invoices are actually complete and they are compatible with the total. In other words, they try to compare, because you may find some invoices have maybe outrage. You find there are some invoices that have a lot of maybe huge amounts, and if you try to do a comparison with what they reported as the total maybe turnover, you find that maybe there are some under or over estimations within the invoices. So you try to sample out some of the invoices to see that you are actually having some relation in regards to what they have reported vis-a-vis what is reflecting in the different source documents that you have seen. So the auditor can sample some of the, they can also sample some of the receipts to confirm what was spent vis-a-vis what was reported in the books of accounts. So those are the things that we can talk about as far as the simple random sampling is concerned. So what we need to look at are the advantages. But what I'm going to do with the advantages and then the disadvantages, I'm going to make sure that the advantages of probability sampling, I just give them at once because they will be applicable. Some of them will be applicable to most of these, especially if I'm talking about the random or what we call probability sampling techniques. Instead of giving advantages of each of the different types of probability sampling techniques, I'm just going to give them all at the end. When I'm done with probability sampling techniques, then I'll give the advantages of probability sampling techniques and then the disadvantages, as opposed to stating a given technique, then I give the advantages and the disadvantages. So let's look at the second type of random sampling or probability sampling technique. We have what we call stratified sampling. Stratified sampling. Of course, stratified sampling, this is a sampling technique applied to a heterogeneous population that can be subdivided into what we call the homogeneous groups, or segments. And these segments are the ones that we call the stratas. But now, what you need to understand is that the population, it applies to a heterogeneous population. Heterogeneous means that it is the type of population that has people with different attributes or different characteristics. It could be they could be items, but they are not the same. They are different. They have different characteristics or different features. That's the population that we call the heterogeneous. Then homogeneous, it means this is the population that has the same attributes or features. For example, you can have a group of people maybe from the same tribe. That would be a homogeneous group. But if you are assessing maybe the entire country, it will be a heterogeneous population because it will have people from different tribes. So what they do under stratified sampling, they group people from the heterogeneous population, and then they create people of the same character, people of the same attributes, they group them together into what we call a sample, and that sample is called a strata. So they keep grouping these people. If maybe they are dealing with the tribes, they keep grouping different tribes in different groups called the stratas. And those stratas, they are the ones now forming the population, the sample. But remember, all these groups are picked out of the entire sample. So one key thing that they make is that they ensure that each homogeneous segment of the population is proportional, or it is proportionally represented in the sample. So they make sure that every kind of tribe, if let's say you are studying a country, every tribe is represented. So these homogeneous groups, they are the ones that we call strata, because it is these stratas or groups that form the sample. Just like, for example, if let's say, if they are talking about maybe manufacturers, they can take maybe manufacturers of maybe television sets, TVs, maybe those who are manufacturing radios, maybe those who are making maybe cameras. This one, they put them into one group because they almost look similar. They are more like identical because they are all electronic devices. But if then they will also group those maybe who are making cement, those who are making maybe paints. They can group these ones as people who are selling maybe housing equipments. So they keep grouping those people in such groups. So stratified sampling therefore involves obtaining simple samples from each of the strata of the population, and these simple samples combined together, they give what we call stratified samples of the population. So this ensures that each homogeneous segment of the population is proportionally represented in the sample. So there are some steps that are involved when you are choosing the items within the stratified sampling. We have general steps. The first step is to carry out the identification of the population strata. You make sure that you get those homogeneous groups. Then two, do the calculation of the proportion of each homogeneous segment. It would be very hard for you to put maybe 20 in one segment, then you put maybe 10 in the other segment. Then the third step is splitting the population sample. Splitting the population sample. Splitting the population sample into proportions, into the proportions above. Into the proportions above. And then the fourth one, is to obtaining corresponding simple samples from each strata. And then finally combining the various simple samples to give the stratified sample. Now, one thing you need to note is that when they give you the population is always mixed up. As I've told you, you can be examining, maybe you can be examining a country. Let's say you are examining a state, let's say Uganda. And within Uganda, maybe you are trying to look at the different characteristics. Of course, we have culture. This would be one of the culture or tribes. This would be one of the distributing the attributes or the characteristics of the people who are living in Uganda. You might find that these people are actually going to be divided into tribes, or we could have things to do with regions. Those who are in central, those who are in northern, those who are in southern, eastern, and maybe the West Nile. Those are regions. So those are some of the attributes within which we can categorize the data. But we know that people who are maybe in let's say in the Western, they may not be almost the same, but at least they have most of the things they do, they look alike, or they have some similar characteristics, depending on the fact that they are living in the same region. Now, these regions or these tribes, they are going to be the homogeneous segments. Now, within these regions, we need, or within this culture or regions, we have to pick people. But we pick people if we have picked maybe in the southern, in the south, maybe in the central, in the north, eastern, and then the West Nile. We pick people, maybe we say we are going to pick 10 from 10 from each of the regions. So since we are going to have 5 regions, then we are going to have 10 people from each of the region, meaning we shall have 10 times 5. That will be 50 people. We shall have 50 people forming out what you call the stratified sample. But these 50 people, they come from 10 from the south, because this is now the stratas, the different stratas, or what we call the simple samples. So these 50 people that formed up the entire stratified sample, they came from the different stratas. That would be the same thing if we were talking about tribes. So that's how we form the stratified samples. So this method is applicable when there is need to, first of all, highlight a particular subgroup within the population, and ensuring that the presence of the key subgroups, for example, the first time, maybe you can talk about first time young mothers, maybe on a weekly antenatal visit to a health unit. Maybe who are at the risk of, who are at the risk among the expectant mothers. So those are some of the key sub characteristics or attributes that we can look at depending on a given population or a given strata that you have selected. Then you go ahead to observe the relationship. You don't just group. Even if you have picked people from maybe southern, you mind about the people you are picking, because you have to observe the relationship between the different subgroups. For instance, you can look at the common attributes that are shared maybe between men and women, maybe who are importers in maybe a Ugandan community. So you look at what do they have in common, and then that will be the basis for you to go ahead and group these people according to where they belong. So that's stratified sampling. Let's now look at the other let's talk about the other category. And the other category, we have what we call the coarse random sampling. This is 3. We are talking about the coarse random sampling. Of course, the random sampling is almost random sampling. It's nearly random sampling. So this technique is not truly a random sampling, but it is a representative of random sampling in certain conditions. So we have some conditions in which this belongs to random sampling. So there are just some representative conditions that make it fall under the random sampling. And it is only appropriate when the random sampling is not possible. So we use this one when maybe it is too expensive to carry out the random sampling, or application of the random sampling itself is not possible. Because we know that there are two techniques that fall under the coarse sampling technique. Here we have two. We have what we call the systematic sampling. Have the systematic sampling, and then we have the multi-stage. We have the multi-stage sampling. So we need to understand what these two are all about. But one key thing is that you have to note that this is only applicable if random sampling cannot apply. So let's start by looking at the systematic. Systematic sampling. Of course, under systematic sampling, we pick what we call a systematic sample. And a systematic sample is a sample in which each member of the population is assigned a number. So this method is used when the population is listed in a given order. When the population is listed in the given order. Of course, some of the examples, for example, we can have maybe row of houses. Or we can have maybe clients visiting a particular web page. Clients visiting a particular web page. A particular web page in maybe in 1 hour. In 1 hour. You look at the number of maybe clients visiting your website. Clients visiting a particular web page. In a given hour. Now, what is going to happen is that the sample is drawn according to some predetermined point or predetermined place or object. So we can maybe choose these items are going to be chosen at random, but they are going to be some predetermined points at which we should choose at random. And then systematically, the samples of any given position or any number of item in the population, then you find that nth number is going to be chosen, maybe depending on the sample size. For instance, we can say maybe we are trying to look at 500 students, and maybe we say we pick the 10th person in a line. Maybe if we line up 500 students or 100 students, then we say we are picking the 10th person in a line. So this technique is particularly applicable for homogeneous population. When the population is similar, maybe we are all looking at students. If maybe we are looking at invoices of a bookshop for one financial year, we know that all of those are going to be homogeneous population for an auditor, provided that their value, maybe the relationship between the books, is not consequential to the investigations, because you may find that these invoices are the same, but some of maybe they are suspicions of over and under estimation of the figures in the invoices. But if these problems are not there, then we just take that those invoices or receipts are going to be the same, so that we can pick, maybe if there were 1000 invoices, we say that we are picking maybe the 20th invoice. We pile them in maybe in a certain box, then we pick the 10th or the 20th or the 5th invoice to be part of the sample that we are trying to formulate. We have some steps. Maybe we can use some steps on how we can pick this, so that we can be able to understand how do we do it, because you can be given a question and they tell you how to help them formulate the sample. This is what we do. The first step, we approximate. If possible, we approximate the population size. This capital N is always a symbol for population. If you are using a sample is represented by a small n. That is for a sample. But a population is always a capital N. So, as long as you know the population size, then the next thing that you are going to do, because this is the first step, the second step is to determine the sample size. The desired, actually it is the desired sample size. You determine the desired sample size. We say the sample size is represented by small n. Then the third step, after getting the desired sample size, you compute the n, which is the population, divided by the sample size, and then round off. Actually, you round downwards. You round down to the nearest integer. You round down to the nearest integer. We can assume maybe, let's call it k, as just letter k. Now that is the third step. The fourth step is to randomly select a number between 1 and k. That k we have computed in step 3, and we call this let's say we call this number, maybe x. Now the final step, this is step 5. The final step is to the sample. This is step 5. Is now to get the sample. The sample will consist of the following individuals or items. So let's look at how the numbers will be. it will have numbers starting with P. Sorry, we called it letter X. That will be one number. Then the next number will be X plus the K that we created. The other number will be X plus 2K. Then we move until we get that number X plus n minus 1 into K. So we base this n, remember this n, where n is the sample size, depending on the sample size that we want to create. Maybe we can have just a brief example to get this idea. Example. I want us to take a situation where we have the population size. Population size equal to 1000. Then the desired sample size is equal to 30. So these two are actually, we are given. So let's now see how we can form that sample. Of course, we have got our n, that is the population, which equals to 1000, then our small n, which is the sample size, equaling to 30. Equaling to 30. So of course this was the first step. This is the second step. Now the third step, the third step is for us to compute the n over n, population over the sample size. So we get 1000 divided by 30. And this will give you 33.333. So we said you round downwards to the nearest integer. What will be the nearest integer here? It will be 33. Even if this is 33.5, we said we round downwards. We don't say it is 34, we just say 35 because we just say 33 because we round downwards to the nearest integer. The reason as why we are rounding downwards is because we don't want these figures to exceed, because if you take this, if it was maybe 33, if it was 33.5, it would have been to 34. But if you multiply 34 times 30, it will exceed this population. So that's why we round downwards, that instead of taking this one to be 34, we take it to be 33. So that when you multiply 33 times 30, you'll get like 9,900. It will be 990 something. So that's why that's the major reason as why. So that the reason as why we don't exceed, we don't round upward, but we round downwards because we always want to be within the population. Because the moment you exceed the population, then it means you have set your own question. Now, the next step, we said we select any number between 1 and k. We said we call this x. Because step 4, we call this number x. Maybe let's pick 5. Then step 5, we now start to give the population. Of course, the population will have a number. It will start with this 5. It will have 5. It will have now 5 plus this 33, comma, it will have 5 plus 2 into 33. Then until we reach to 5 plus, what is n minus 1? It will be 30, which is our sample size. Is 30 minus 1 times 33. So we go up to when we have 5 plus 30 minus 1 times 33. So you'll find that your sample size will be equivalent to the sample size will have 5, which is this 5 here. When you add 5 plus 33, you get 38, comma, you get 5 plus, of course this is 66 plus 5, that is 71. Then you move and you solve also this one. This one will give you a 962, and that will be your sample size. So that's the systematic. That is the systematic sampling. So we need now to look at the multi-stage sampling, which is the other item within what we call the coarse random sampling. So this one is multi-stage sampling. Multi-stage sampling, of course, this method is most suitable when the population is spread over a relatively wider geographical area, geographical area or location. So it can be used if the population is spread over a very wide area. Like for instance, we have spoke about if we are carrying out a survey on Uganda as a country. We've said Uganda is going to be having a lot of very many people that are spread in the various parts of the country. So what we do is that we use the following steps. Of course, it also has steps that we follow. One of them is splitting the area in two regions. Now this one is also best if you are using, maybe carrying out a study about the global or about the entire world, all the countries in the world. You can divide them depending on the continent. You take maybe Africa, Asia, then you study them as such. So you split the area into what we call regions. You can, if it is Uganda, you take southern, eastern, western, northern, then West Nile. Then you carry out you randomly selecting the sample, from the regions, You see, you pick the samples from those regions that you have created. And that's why we are saying that this is applicable when the population is too big. So when you have selected the samples, then you go ahead to randomly selecting the samples from the major towns. Because for example, we can select that maybe in the eastern, but eastern is so wide we can't study all the eastern. We can pick some major towns like Mbale, like Solonko, Manafa. We pick some of those cities, then we study them. So we have picked a region, let's say we have picked eastern to be our sample size, but within that sample size we also form a sample size from different cities. Then the last one is now, the second last is splitting the samples of towns, of major towns into zones. Even within the cities that you have selected, they could be so big. Just imagine if you had picked maybe Kampala from the central. You can also divide Kampala into divisions or different zones. Maybe you take Kawempe division or Kawempe zone, then you take Nakawa, depending on those different divisions. Now it will be within those zones that you have formed. That's where you will pick the final samples. but still you also do what? You use a random sampling. So a sample is then selected from the zones. This is just a simple illustration to clarify what we have talked about. We've said if, let's say, you are looking at a country, you can pick out regions. Maybe this is East, maybe this is Central region. Then within these regions, you also come and pick out cities in those then within those cities you go ahead to pick what we call zones. Zones, they could be, you could take them to be maybe municipal. Then now it will be from these last zones where you will pick samples that will form what we call the big sample that we are going to study. So that's all about the multi-stage. So it looks at the population. When the population is too big, you keep on randomly selecting samples from different regions. Then you look at towns, you look at zones. Zones are like villages, or they are like LOCs. So that's how we collect information. So the process goes on until the desired final sample is achieved using either the methods that we have described above. So you have seen that the coarse random sampling, it is used when the random sampling can't work or it is too expensive to be carried out, because this one is a little bit technical. So let's look at maybe the advantages. The advantages of probabilistic advantages of random sampling. We said random sampling is the same as probability sampling. So we are going to mix for all the different types. One of them is the fact that it takes less time to accomplish. I'm just going to highlight them. It takes less time to accomplish. Of course, this is specifically for the multi-stage, because once you keep on grouping, you end up saving time. It also requires a small manpower or labor. Manpower to execute. meaning it's cheap. The other, it's less costly. It's less costly. We can also add that less costly and easy to implement. Less costly and easy to implement. Of course, the samples that we have collected are going to be representative of the entire population. So the samples collected are always representative of the population. Then it saves time. It saves time and eliminates bias. Saves time and eliminates bias, or the bias could be for the researcher or for the other people. Then it ensures better coverage of the entire population. Ensures better coverage of the entire population. So those are some of the things that we can talk about as far as the advantages are concerned. So let's look at the disadvantages. Disadvantages of the random sampling. One of the disadvantages, it is subject to bias, especially when few regions are selected. It's subject to bias, especially when few regions are selected. Because if you ignore some of the regions and you select information from some from some sections, then you are going to find that you are going to have a biased information. Then the other one, it's also time consuming. It's time consuming, especially if you are organizing the people into different stratas or different regions. Then the other problem is that it needs to list the population. It needs population listing. There is a need for population listing, and at some point it can be costly, quite costly, when the population, especially when the population covers a wider area. When the population covers a wider area. When the population covers a wider geographical area. So those are some of the advantages and disadvantages of probabilistic sampling. So what we are going to look at in the next video is going to be about the non-probability sampling. And when we are done with that, we can be able to look at the methods of selection, especially for random samples. I've given you some of the things that we can use to select random samples. I've told you about the football match, where you can select that information. The football match, of course, even in lottery, there is those kind of lottery methods where they select they are mainly two, actually. They always use the lottery method and then the table of random numbers. So these ones you can study about them, so that when you come back we look at what we call the non-random sampling methods. Then once we are done with that, we will just look at the different types, like the cluster and then quarter sampling. When we are done with that, we can be able to look at the advantages and disadvantages. Then we finalize the chapter 3. So we'll see you in the next video.